Ed and Adelaide attend the same high school but are in different math classes. The time E that it takes Ed to do his math homework follows a normal distribution with mean 25 minutes and standard deviation 5 minutes. Adelaide's math homework time A follows a normal distribution with mean 50 minutes and standard deviation 10 minutes. Assume that E and A are independent random variables. All right, so let's just summarize that real quick. So E is approximately normal with a mean of 25 and a standard deviation of 5. A is approximately normal with a mean of 50 and a standard deviation of 10. Okay. And they're independent. All right, part A. Randomly select one math assignment of Ed's and one math assignment of Adelaide's. Let the random variable D be the difference in the amount of time each student spent on their assignment. So D is equal to A minus E. Find the mean and standard deviation of D. Okay, so the mean of D is simply the mean of A minus the mean of E. Right? If you subtract the variables, then you subtract their means. Right? And so this in turn becomes 50 minus 25, which is 25, right? On average, if you select one of Ed's assignments and one of Adelaide's assignments, we expect the difference in the time it takes them to be about 25 minutes. All right, to find the standard deviation of D, it's not so straightforward. Okay, so first let's go through a couple of common mistakes that students will do, right? So students will think, okay, well, if I subtracted the means in the last calculation, then maybe I should subtract the standard deviation. So maybe I should go standard deviation A minus standard deviation E. Okay. Now, that doesn't work because sometimes you might get a negative value. Okay. Like if A had a smaller standard deviation than E, which is not the case in this problem, you'd end up with a negative difference, which doesn't make any sense, right? Standard deviation can only go as low as 0. Okay, so then we could add, right? We can add the standard deviations, but unfortunately that isn't the correct way to do it either. Again, that's another common mistake. What we need to do is we need to add the variances, okay? And that'll give us the total variance, and then we'll have to square root the result to get back to standard deviation. Okay. This is often referred to as the Pythagorean theorem of statistics, right? You might, okay, I don't want to make this video longer than it needs to be. So this is how we're going to calculate it. All right, so this is going to be, let's see, 10 squared plus 5 squared, and then we'll root the whole thing. Right, so that's the square root of 125, about 11.18. Okay. Right, all of these units are in minutes. So in the long run, if we surveyed many days from Ed and many days from Adelaide, on average the difference in their homework time would be about 25 minutes, and that difference in time will typically vary by about 11.18 minutes from the mean. Okay. All right, part B. Find the probability that Ed spent longer on his assignment than Adelaide did on hers. Okay. So we want to find the probability that Ed's time is greater than Adelaide's time. All right, what if I took this inequality here, and what if we subtracted E from both sides? Okay, then it would become the probability that 0 is greater than A minus E. All right, so I'm just using algebra to do some rearrangement. Why did I do that? My goal was to get to A minus E because I know A minus E is equivalent to D. So now I can write this as the probability that 0 is greater than D, which is the same as saying the probability that D is less than 0. All right, so this is what we're going to try to find. What's the probability that the difference in Ed and Adelaide's times is negative? Now, going all the way back to the beginning, right, our random variable E had a normal distribution, our random variable A had a normal distribution, so our random variable D will also have a normal distribution because it was derived from two variables that were normal. Okay. So here's what we know. D is approximately normal. The mean of D is 25 minutes. We just calculated that in the last step. The standard deviation of D is 11.18 minutes. Okay. All right, let's draw ourselves a picture. All right, that's the mean, 25. Our boundary value is 0, which is going to be somewhere over here. And we're looking for values less than 0. So I'm going to shade the left tail. All right. So since this is an FRQ problem, we want to show all our work, meaning we want to first standardize our boundary value. So 0 minus 25 over 11.18, and that's going to be a negative something. Negative 2.24. Okay. And then I can go to table A and get the area. Okay, negative 2.24. Okay, so negative 2.24 is 0.0125. Right, and that's the area, which is the probability. 0.125. Okay, so it's very unlikely that Ed would spend longer on his homework. Because again, remember, what do you expect? You expect Ed to spend 25 minutes and Adelaide to spend 50 minutes, right?